Hi there! In my last video when I started work on the crankcase, I goofed up a little bit. When I was double checking that the piece was centred on the rotary table, I turned the rotary table instead of turning the actual spindle that was holding the gauge. And Mike of Mike's Adventures quite rightly pointed out that problem. So I've pinned his comment at the beginning of that video. But anyway, in this video what I'm going to be doing is hopefully completing the crankcase for the Jerry Howell V-twin. Now Dave Ticehurst, he's based in Australia, and he's been a machinist all his life, I think, and he provides me with some really good help and advice. And he's just recently put a video on his channel, a very short one, about marking up and centre punching. And unfortunately I'd marked this up prior to seeing that video, but I will try and adopt some of his working practices in the future. So in my video description I'll put a link to his video. It might be of interest to others. But anyway, on this crankcase, what I decided to do is to mark up the areas where I'm going to bore through the holes that are going to hold the cylinder or cylinders. Now what I did first of all is I determined the exact centre point, and the way I did that is I put it on the marking up table like that, measured the height, divided the height by 2, and then scribed that line, and I turned it round again and scribed it again to make sure I was spot on centre, which I was. And then based on the drawing I worked out that this dimension here is 0.6 of an inch, so that actually made the centre from this edge to be 1.475 of an inch, and I scribed that line. And having determined this centre point here, I then determined these other points. And I also marked up some of the front as well. So initially I think what I'll do is I'll go over to the mill and I'll start machining these areas. Well, I've used a few methods to try and get this top level with the bed. So this is reading 0.03 and a little down arrow. Put it on there. It tends to be a bit random. Down arrow 0.04, so that's pretty close going by that. I also used this as a check, and finally running this gauge across. Pretty close to me. So I need to find this edge. Once I've found the edge I need to zero the DRO, then I need to move the table that way 3mm, because this is 6mm wide. That'll put the spindle exactly on the edge. Once I've done that, I need to move the table again by 1.475 of an inch, and that should put me on this line here. I generally use marking up as a guide, so I rely upon the DRO, to be honest. So 3mm, zero again, move to imperial, .475. Lock the table. So what I need to do now is to use this edge finder and find this edge on this far boss here. Having done that, I'll zero the DRO, I'll bring the edge finder up to this edge here, find that edge, then I'll use the DRO to divide the total width by 2, and that'll put me in the centre. Table 0, so just centre drill in the centre. So while I've got this centre drill in here, I'll just centre drill the positions where I'm going to do the threading for the 4 bolts. And these are 0.625 of an inch from the centre on the X and Y axes, but I'll do that bit off camera. Well, nothing seems to go to plan these days. When I centre drilled on these 2 holes here, the part slipped, so I had to get it back level and then re-centre, so I've decided to drill and tap at the same time. Get that job out of the way. Well, I could have kicked myself when I realised that this had tilted ever so slightly, but I suppose that's the advantage of doing the marking up as well, because that was a double check. I realised mistake pretty early on. But anyway, this time round I've decided to offer a bit more support by putting this block in here and bolting it to the table, and also I've managed to nip the vise up a bit more, so fingers crossed we'll be okay for drilling the hole through here that's going to hold the cylinder. So this needs to be opened up to 1.189 of an inch with this boring head. So I'll take a measurement and find out how far I need to go. So the internal bore currently reads 1.016 of an inch, so my target is 1.189. Take 1.016 off that, I get 0.173 of an inch. Divide that by 2, I get just round about 86 thou. That equates to 2.197 millimeters. So I need to use this boring head, turning round about 10 increments at a time, which is about 0.2 of a millimetre. So I need to do will be 2 full turns of the dial and 9.8 increments. So I'll get back to you once I'm close to that dimension. .1825. So the target is 1.189, and I measured it again. I reckon it's 1.183. So that's 6 thou to come off. Divide that by 2, you get 3 thou, which is equivalent to 0.0762 millimeters. So that's 3.81 increments on the dial. So I'll adjust it by that amount and make the cut, and then I'll get back to you. Well, I reckon that's spot on 1.189, so I'm very happy with that. Now there's a need to counterbore this to a diameter of 1.32 of an inch and to a depth of 63 thou. So on the spindle I've zeroed, well, I touched the tool on the top of the part and zeroed the sort of DRO on the spindle, so I can get to that depth of 63 thou easy. And the difference in the diameter is 0.131 of an inch, so divide that by 2 is 65.5 thou, which equates to 1.16 millimeters. So again, I'm going to move the tool out by around about 0.2 millimeters at a time, and then just cut to a depth of 63 thou. Keep on doing that until I get to the diameter of 1.32 of an inch. So that's one cut at 63 thou deep. So I'll carry on until I get to the required diameter, and I'll get back to you. And the final cut. Now, a while back I decided to buy the pack of bearings and screws and o-rings from the Howell website, and they seemed quite expensive initially, but when you consider that in UK I'd have real difficulty sourcing some of these, and I'd have to go to various suppliers. So at the end of the day, it probably is a lot cheaper buying from the Howell website. And this is the o-ring for this particular bit. Looking good. So I'll repeat exactly the same process on this side here for the other cylinder, but I'll do all that off camera and then I'll get back to you. So here I'm just putting some straight edges on the sides and the top. Well, it's gradually taking shape, and I've left these bits here intact because it's easier to hold it in the vise. And I think the next step is to machine this bottom bit out here. And I have noticed that the inside of this needs to be turned as well. There's about let me see, 187 thou to come off the inside of that, sort of a recess. So that should be interesting. Not too sure how to do that. But anyway, I'll put this in the vise and I can start machining this bit. So I used a gauge in the normal way to just check that that's level, and then I used an edge finder on all the edges to find the centre point. And I've determined that to cut out the inside bit, this edge here, in line with this 3/8 of a millimetre 2-flute end mill, the DRO needs to read, let me see, 0.5295. So I've set the spindle at that position. Now on the x-axis I've determined that the end point here should be minus 0.9825, and likewise the other side plus 9825. So what I've done is set my end stops on both sides just short of that measurement. So what I'm going to do is I'm going to use the power feed to go up and down, keep on cutting at light depths until hopefully I manage to get through. Once I've done that, I'll do the other side and then these sides. That's the plan. Okay, so I've had a bit of a rethink, and it's probably better off just plunge cutting and then finishing it off with the power feed. So that's what I'm going to do. I think that's a better method. Well, this plunge cutting seems to be working well. Now it's just a matter of tidying it up with the power feed on the table. Well, that seems to have turned out pretty well. I cut a bit of a shelf in there. That will hold a plate later on, held with something like JB Weld. And see that ledge there? What I need to do now is to, where that ledge is, open it up, open a radius up inside. Which is going to be a bit tricky, I think. I don't think I can do with that with a boring head on the mill, so I think I'm going to have to put it onto the lathe and then use a boring bar at an angle. So once I've set it up, I'll get back to you. So that's pretty close on the 4-jaw chuck. I've also had the gauge on the face, and that's pretty close as well. Well, this is probably quite difficult to see, but the tool is pointing sort of like roughly 45 degrees towards that direction. I've put carriage stops on both sides of the carriage, so the plan will be to withdraw the tool to me by about 1/10 at a time and see if I can cut in here. Might be difficult to see this on camera, but we'll give it a try. Well, the plan seems to be working, so I'll continue off camera and then I'll get back to you. So spot the rail one. It's actually turned out pretty good. I'm very happy with the result. Everything is nice and perpendicular, which is key for this component. So I'm pretty happy with the result. The only thing I messed up on is, which I mentioned previously, one of these, when I centred that, when I centre drilled it, the part moved, but I managed to recognise the problem early on, so I re-centre drilled and then tapped. So it's, yeah, I'm pretty happy with it. The only observation I would make is, even when you drill these holes to the spec, I think it's 0.35 of an inch or something like that, they still sort of like just peep out at the bottom. And I drilled these before opening the centre up. Maybe if I was to do it again, maybe I would open the centre up first and then drill right through and tap the whole length, and maybe then just put a little bit of JB weld or something underneath to seal them. So apart from that, to get this sort of curve here, I used a centre drill, and that one turned out reasonably well. Just needs a bit of filing there, I think. But this one, I don't know why, but this drill went off centre. So I think I'll use a bit of JB weld, or probably some epoxy with some aluminium powder in. That seems to work pretty well. But all in all, very happy with it. I tapped these holes here just using the bolt circle function on the DRO, so I just centred it using a coax, and they seem to have turned out okay. So all in all, a result, I think. There are a few minor things that I've not done, and that is drilling some holes for the oil ways, which I'll do probably later on, and just drilling some holes through here for the bolts to hold it to something, but I'll leave that until later, until I know what I'm bolting it to. Well, I'm pretty chuffed with the way that's turned out. And recently I've been thinking about gears, and the design calls for some gears to be made using 48 DP cutters, and I'm really struggling to find a supplier of the 4 cutters I need. I need a number 4, number 5, number 7 and number 8. Now I did some work on CAD to see whether I could redesign the gears to be mod 0.5, which actually requires the centres to be slightly different, but I really don't want to do that because I want to stick to the design if I can. And I've just had an inquiry with RDG to find out you know, when they might get some cutters in. They've got a number 5 and a number 7 in stock, and they've got an order placed for a number 4 and number 8 cutter, but it could be several months before they get those in. So they suggested that I order the number 5 and number 7 from them now, which I've just done. So I'm fairly committed now to 48 pitch gears. but I do need to try and source number 4 and a number 8 cutter. So I'll have a look around. There's some cutters on eBay, but I'm not too sure whether or not the angle's the same as the ones that RDG are selling. But anyway, if anybody's any sort of thoughts on that, if anybody's got a number 4, number 8 cutter that want to flog me, I'd be interested. I'm not really into borrowing stuff, because I once lent some tools to somebody and I never got them back, so you know, I wouldn't, not that I wouldn't send them back, but I don't really sort of believe in that. Like I say, if anybody's any ideas on that, I'd appreciate it. I did actually find a place in the States, but their cutters were about $80, and when you considered shipping and everything like that, it was just wasn't cost effective at all. But like I say, if anybody's any thoughts on that, I'd appreciate it. But in the meantime, I hope you enjoyed the video, and I hope to see you later.